All right, in this set of examples, we want to take a bunch of arithmetic sequences and we'll be given different pieces of information about them. So either they'll give us the first four terms, or they'll give us some random term and the common difference, or they'll give us two random terms. And in every case, we want to come up with the explicit formula. And just to remind you what that looks like from the previous video, it looks like this. That right there is the general formula that would allow us to find any term in this sequence. A sub n is whatever term we're interested in finding, or the last term. This right here is the first term. D stands for the common difference, and common diff, I'm just going to abbreviate that. And then n is the number of terms in the sequence. Okay, and then this right here is the nth term, whatever term we're interested in at the moment. If we want the 100th term, then the nth term would be the 100th term. So that's our three goals. And then secondly, we want to be able to take a series where a bunch of things are missing, like you see there in number 4, and find out what's missing and how to do that. All right, so let's try number 1 first. And as always, if you come to a point where you feel like you can give the other ones a try, or even if you don't, see if you can challenge yourself and try to find the next value. All right, so right here we want to find the nth term. So we can always start by finding the common difference. That's always a good starting point. So it looks like to get from 17 to negative 3, if we subtract those, we get negative 20. And then same thing, we subtracted 20 again, we subtracted 20 again. So our common difference part of this is going to be negative 20. And then our first term will be 17. So now all we need to do is just simplify this out, and then we'll distribute that right there. So negative 20n plus 20, and 17 plus 20 is equal to 37. So 37 plus negative 20n, that would be our result. Again, what's the utility of that? What would that be used for? Well, now that you know that, you can find any term that you might want to find in that sequence. If you want to find the 100th term, all you have to do is plug in 100 right here for n, and you'll be able to find that. All right, the next one right here, we want to again find what this formula is going to be right here. So here's the challenge. In this case, we do know D. We know that D is equal to 8, so we can at least fill that in right there. But however, we don't know what, or sorry, I said 8, but it should be negative 8. We don't know what the first term is, and that's a problem. So what can we do about that? Well, here's what we do know. We use the information that we're given. So we don't know the first term. We do know the 12th term, though. So let's do this. Let's take a sub n, and let's use a sub 12 right there. And a sub 12, we're told, is negative 94. Okay, we don't know the first term, so we're going to leave it as a sub 1. We do know this is negative 8. And we do know that because we're using the 12th term, n in this case would be 12. So n minus 1 would be 12 minus 1. Why are we doing this? Because this will allow us to find the first term, which we can then use in our explicit formula. And another name for that, by the way, that's called the nth term formula, because it helps you find the nth term, whatever term you're looking for. So now we can solve this. So this right here, that's equal to 11. So negative 8 times 11 would be minus 88, or negative 88. And then we can solve that right there by adding 88 to both sides. And we would get negative 6 is equal to a sub 1. So our final answer here would be a sub n equals, we just found out what that is, that's negative 6, plus we knew all along that that was negative 8. And then we can simplify that as always. So a sub n equals, that's going to be negative 8n plus 8, and then we still have that negative 6 right there. So our final answer to that will be a sub n is equal to negative 6 plus 8 is going to be positive 2. So positive 2 minus 8n, and it doesn't matter if the number comes first and the n comes second, or vice versa. All right, so that's how you do it if they give you a random term and the common difference. What if, this is probably the hardest case, what if they give you two random terms? So here we're given the 14th and the 38th term. We have no idea what the first term is, and we have no idea what the common difference is. So this one is a challenge. All right, so here's a much simpler example. I always think it's easier to take harder problems, break them into simpler examples. So suppose that I give you the second term of a sequence, and I told you it was 10, and I give you the fourth term, and I told you it was 20. And the first thing I want to know is, what's the common difference? So we don't know the first term. We know that the second term is 10. Don't know the third. We know the fourth term is 20. And the question is, how much do we have to be going up by each time? Well, think about it. You went from 10 to something, and then you went from that something to 20. So that's a total traveling distance of 10. From 10 to 20, you went a distance of 10. How many jumps did it take you? Well, you did it in 1, 2 jumps. So if you must have divided that 10 over the course of 2 jumps over terms, that means you went 5 each time. So that the only way that would work is if that's 15, because then you're adding 5 here and adding 5 here. So basically what we did here is we took our total distance that we traveled, and we divide it by the number of terms that we traveled. So in this case, we went from the second to the fourth term. That was a distance of 2. That's where that 2 comes from. And our distance traveled 10 came from going from 10 to 20. Let's apply that same reasoning right here. So total distance, dist is just going to be abbreviation for distance, over number of terms. This is going to give us our common difference. And once we have that, we can do, then it's going to be a problem exactly like number 2 where they gave us the common difference. So what's the total distance? We went from 294 to 774. So we're going to subtract those, and that is going to come out to be 480. How long did it take us to do this? Well, we went from the 14th term to the 38th term. So whatever the distance between 38 and 14 is, that turns out to be 24. And that gives us a common difference of 20. That means we're going up 20 each time. So now we can do this. So now we know A1, we don't know that. We know that the D is 20. And now what can we do? Now we're back at a problem like number 2. So see if you can finish this right now by plugging in either one of these points. I'm just going to plug in A sub 14. So A sub 14 is 294. Still don't know A sub 1. We know this is 20. And we know since we're dealing with A sub 14, that means N right here has to be 14. So 14 minus 1. Alright, now we can keep simplifying here. So we have, if we distribute 14 minus 1, we don't have to distribute that. 14 minus 1 is 13. So this equals 13. So 20 times 13 is 260. And that's still, add that to A1, you still get 294. Let's subtract the 260 from both sides. And we would get 34 is equal to A sub 1. So our final answer will be A sub 1, which we just found, plus D, which we knew from before, times 20 minus 1, or n minus 1. And then when we distribute this right here, we get 20n minus 20. And that comes out to be 34 minus 20 is 14, plus 20n. That is equal to our nth term. That's as far as we can go. Alright, the last one right here. By the way, the missing terms right here, and actually let me clear off this writing because it's a little bit messy otherwise. The missing terms on number 4, those are called arithmetic means. And I'll write that down. So arithmetic means are basically the missing terms in a arithmetic sequence. And that's what our task is. And we kind of did this in number 3, so I would challenge you to try to pause it and see if you can figure out from the reasoning we used in number 3. Alright, so let's think about it. So we're going from 18 to 63. That means we traveled a distance of 45. That's the difference between those. And we want to know how many terms did we travel. So it looks like this term, there's 1 jump, there's 2, 3, 4. Looks like it took us 5 jumps to do that. So we traveled a distance of 45 in 5 jumps. That means we went 9 each time. So the way that you can check that you're doing this correctly is start adding 9 to these numbers, and if you wind up at 63, then it will work. So let me show you the wrong way to do this. Imagine that instead of 9, somehow I got 8. So 26, that would be plus 8. If I add 8 again, it's 34. Add 8 again, that's 42. Add 8 again, that's 50. Now 50 plus 8 is not going to be 63, so I know that I did it wrong if we used 8. So let's use 9 because that's what we got, and hopefully this will work. So 18 plus 9 is 27. 27 plus 9 is going to be 36. 36 plus 9 is 45. 45 plus 9 is 54. And sure enough, when we add 9 to 54, we do get 63. And so that is how we can find the missing terms.